Welcome back to my video channel. I'm Miss Lisa. I would like you to like, share, subscribe because I want this to be easier where I can do it directly through YouTube Live and not have to record it and then upload it. This is a class primarily designed for homeschoolers, but if you like the way I explain things, come on in. We're going to be talking about energy sources. This class is physical science. We're going through this book, but you don't have to have this book to learn about energy sources. So if you watched the last video, we talked a lot about energy sources, and I already talked about most of this chapter without realizing that this was a separate chapter in this book. So this might be a very short video. We'll see. All right, so energy. Energy is important when we learned what it was in our last chapter. And what this chapter is talking about is more commercial energy. So one of the sources that we have for commercial energy is something called fossil fuels. And it is petroleum, gasoline, natural gas, coal, oil shale, oil. All of those things are fossil fuels. Now, why are they called fossil fuels? It is because a long time ago, the earth was covered with a lot of ancient ferns, and this would be like in the time of the dinosaurs, and something happened where they were buried with a lot of pressure, and that as they were decaying, instead of just regular decay, instead they were converted into these materials. So it used to be old gasoline ads would have dinosaurs, and then it would turn into gasoline. Also at Epcot, it became Ellen's Universe of Energy, but before that it was just the dinosaur ride put out by the gas companies, and it would have these dinosaurs, and then it would talk about how they become energy, and it's our gasoline and things like that. They're fossil fuels, and there's debate on what exactly happened to cause it and to make the conditions right for there to be that pressure in addition to decay, because like things die and decay now, and they don't usually become fossil fuels. So there was something right about the conditions that caused that. Now, petroleum or crude oil are these deposits of oil that are in the earth, and they are pumped out, and then they're purified. So you are a carbon-based life form. So you are made out of chemicals that spell CHNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, CHNOPS. But the main two are carbon and hydrogen, the first part of that word, the ch. And so this is the elements that make you up. Remember the elements from the periodic table. And if something is just carbon and hydrogen, it is called a hydrocarbon. And they're bonded together. And the reason why carbon's so special is it makes something called tetrahedral bonds, which gives it great variety. There are millions of these chemicals that are carbon-based. They're called organic chemicals. So these things that this fuel came from were living things. They too were carbon-based life forms, plants and animals, and then it became these fuels, and they are hydrocarbons. They're made out of carbon and hydrogen, just like those other things. When you get the oil out of the ground, it's all mixed up. There's all different kinds of hydrocarbons, and they're more useful if we separate them out. So they use a process called distillation, where they heat it up, and different chemicals will boil off at different temperatures. So the ones that boil off first, they take off that vapor, and then they recondense it, and they have it. And then they take off the next thing as it heats up a little bit more. Then whatever that next lightest hydrocarbon will change from liquid to gas to vapor, and then they can condense it in this process called distillation. And yes, it is similar to what people use in making alcohol. Back in the South during Prohibition, there were lots of people who had illegal moonshine making stills in the mountains here, and they would make their alcohol stuff, and then they would heat it up to get the alcohol off of it, because they didn't want all the corn and all the mash stuff. They just wanted the alcohol part, and they would use that same distillation process. All right, so different hydrocarbons come off at different points depending on how small they are. The smallest ones come off first. At the very bottom, you get the real big ones, the ones that have, one has a chain, where this one has a chain of 3 carbons. There's one with 25 carbons that's asphalt. Asphalt is one of the things that we make roads out of, is one of the things that you can get from this oil. So now what do we do with the oil? Well, we burn it and make roads out of it and stuff like that, but we can also build with it. I used to teach a chemistry class where they had a chapter and it said petrochemicals, to build or to burn. So we make lots of things out of petrochemicals, plastics, nylons, even some vitamins are made with petrochemicals. Anything that, a lot of fabrics are made out of petrochemicals. So my little plastic glasses right here used to be a fossil fuel. It used to be some sort of dinosaur or something. If your clothes are cotton, then it's not a petrochemical. But if it's any kind of nylon, acrylic, I can't say it, lycra, any of those would have been a fossil fuel at one point. So, and then all of the plastics, so like things like artificial hearts and tubing, important things from hospitals, they're all made from these plastics that are made from oil. So the debate was, since there's not fossils or these old dinosaurs and ancient ferns around anymore, and eventually we're going to run out of this stuff, maybe we shouldn't burn it. Maybe we should only use it to build things out of. And that was the sort of debate in that book. So now, what are some of these other things besides just the oil? Also, natural gas. Above the oil, a lot of times there's a pocket of gas, and this would be like methane, ethane, propane, those fuel gases. They just found a huge deposit of natural gas off of the coast of Israel. It's called the Leviathan Oil Fields. And when they first discovered it, they knew it had the natural gas. They didn't know if it had liquid oil underneath it. And now they found out it does. That it's probably the world's largest deposit of oil. And that could cause some conflict, because there are some people who don't like Israel and who don't like them having control of this. So it'll be interesting. It's interesting because this is one area where politics has something to do with science. So it's kind of interesting watching it. Another one is coal. And with coal, it is in a solid form. You've seen coal before. You've seen charcoal. And coal can be made, charcoal can be made by wood now. But coal is also a solid fossil fuel. So there is ancient coal that is found in mines. Coal miners pull it out, and it's used to generate electricity. So last time I talked about how you can burn coal to generate electricity, to move the magnets around the wires that make the electricity. You can use a hydroelectric dam to use the water falling to move the magnets around the wires and make electricity. You can use wind. You can use other things to move the magnets around the wires to make the electricity, including nuclear power, where they use the heat from the nuclear rods to boil water to make steam to move the magnets around the wires to make electricity. And that's what the coal plants do too. They use the coal, they burn it to boil water to move the magnets to make the electricity. And our homeschool group went on a field trip and saw this at a coal plant north of here, and it was really interesting. We got to go look and see the fire, and we saw how coal used to be very, very dirty, a very bad for the environment form of producing electricity. They really clean it now. There's no pollution coming out of this, and they talked about how they clean, how they scrub everything before it's released back into the environment. And it was an interesting field trip. You had to be a certain age. I think you had to be 12 to go on it. You had to wear closed-toed shoes, and you had to wear pants. No skirts allowed. So you had to be like real safe and kind of athletic because you had to climb around. But it was very interesting. So, and it was free. So you can contact your local power place, and they might let you go on a field trip. And that would be a great thing to do with this unit. You should do it right now for your science class. Go on that coal power plant field trip, or if you live near a nuclear power plant, I don't know if they let people tour those. I would think maybe not, but or a hydroelectric or wind, any of them. You should go on a field trip, and that'd be fun to do, and you should go do that. We enjoyed it when we got to do it. I had always wanted to go, and all those years of teaching science, and finally we got to go on the field trip, and it was awesome. I loved it. All right. All fossil fuels are non-renewable. That means you can't make more of them. So there is a push to conserve fossil fuels. And an alternate to fossil fuels are nuclear fuels, where you take radioisotopes like uranium, and as it decomposes, it splits into new elements, and when it does, it gives off energy because of E = mc squared. So when an atom splits, it's called fission. I always tell kids to imagine that their hand is a fish and cut it so that they can remember that splitting the atom is fission. It's not fission, it's fission. There's no H, but it sounds like fish. So fission, so take your hand and cut your fish. It's splitting the atom. And then the other thing that is nuclear power is fusion, where you fuse the elements together. So then take your hands and pat them together. You're fusing them together. And that's where the little elements like hydrogen can be fused together into bigger elements like helium. And that's what's happening in the sun right now. The sun is burning because the extreme gravity is fusing the hydrogen into the helium. And once again, tremendous energy is given off because of E = mc squared. Einstein's famous formula. All right, so you can see the fission in your book. You can see how the nuclear power plant works. The problem with nuclear, there's problems. One is disposal of waste. The waste is radioactive. Radiation can cause radiation poisoning and cancer and death. And so nobody wants it in their backyard. So what do you do with it? One of the ideas now is to seal it up and put it into salt domes, that they think this salt is going to hold it and keep it away from people. I don't know about that. The other problem is you can just have accidents, things like leaking like 3 Mile Island, or them blowing up like Chernobyl did, or in Japan they had an earthquake which destroyed the nuclear power plant, and followed by a tsunami. So then all that radiation got washed out. All these people died. I read one report that said it was estimated that 20,000 Japanese women lost their unborn babies because of that. So that's very sad. 20,000 babies. And then because of the nuclear disaster, it's so hot, anything they send in there to try to clean it up, it melts. So they've tried sending in robots and it melts them. So it's just still leaking into the ocean, way later, years later now. And that radiation has made it all the way across the Pacific and is in California now. So, people don't want to go swimming in radiation. So this is an area where you will have to make up your mind as a voter. But I'm starting to think that I'm not for it, that I'm not for nuclear power, that, it's great that it doesn't have pollution and stuff like that, but it just seems to me like the benefits do not outweigh the risk. But you'll have to make up your own mind, but especially after seeing what happened in Japan. We can make these places very safe, but not earthquake safe. Japan did everything right, and still lots of people died. All right, so we have alternate energy sources like solar, because the sun keeps burning. You can have solar panels where you get electricity. Hydroelectric dams, we have one here. A lot of our electricity in this area comes from hydroelectric because we have Lake Lanier and we have a dam that makes electricity on it. One of the problems with that is sometimes it keeps fish from migrating. So now they put little stairs for the fish to swim up to get over the dam. I don't know if our dam has that here in Georgia, but we don't have salmon migrating either. That's more an out west Pacific thing. Also, they can get energy from tides. But what's happening with that is that as the tide moves in and out, they can use that motion to make the electricity. They're ugly. And so people don't want their pretty beaches messed up with ugly tide. Beaches have a commercial value for tourists and the beach and all that. And that sort of outweighs the messing up the beach to make it ugly, producing electricity. So if they are going to continue with the energy from the tides, they need to think of some way where where that's considered, where it's still pretty, where people can still use the beach. And probably people can't use the beach there because, water and electricity, you end up getting shocked. Another one is wind power, and there's problems with that. Birds, and we have protections for birds. There are endangered species we want to protect, and the birds don't understand these windmills to stay away from them, and they dive into them, and it slaughters birds by the thousands, all these endangered birds. And it's against the law. It's illegal to kill an eagle or these big birds of carrion, and these windmills do. So that's a problem. They're bird killers. So there's so many aspects to all of these problems. Another idea is a geothermal power plant. You can use the heat produced in the earth to boil the water, to turn the turbine, to move the magnet, to make the electricity. And they do that a lot in Iceland. I think all of their power is produced with geothermal springs. So that's kind of cool. We don't have those around here in Georgia, but for the places that do, that sounds like a great way to make some electricity for free. Also, there are alternate fuels that instead of burning gasoline in your cars, now it's a big push to have the battery-powered cars. And also there's alternate fuels like hydrogen gas is one that people have looked at, and using natural gas to power cars. So, and even old oil, people are using old cooking oil and putting it in diesel cars, and instead of throwing the old oil away, they can use it to power their cars, which, how smart is that? That's really cool. All right, so that's chapter 9. We'll next be moving into waves. We're going to be talking about sound and light, always one of my favorite parts of physical science. So come back next time and we will talk about that. I'm Miss Lisa. Like, share, subscribe. Science is great.